What is up, YouTube? It's another week of JavaScript with Joe. We're on day 16 today of the Advent of Code challenges. If you've not seen them, every December there's 25 programming challenges, sort of familiar to sort of a tech interview, and we're on 16 of them. You can see through the stars. We've successfully completed some of them with 2 stars. We've half completed some of them with 1 stars. We've had a bit of a streak of not really finishing anything at all. They've definitely got a lot more sort of algorithmic and difficult in the last few weeks, but that's programming. Sometimes you can't solve everything. I time box these at 1 hour, so we will definitely be done by 5 p.m. UK time. Try to be sort of, try to finish the first half in half an hour, second half in half an hour, but we'll see. So we might end early if it's an easy one. And today we are on day 16, which I will also link in the chat. And all the code will be available on replit.com, which I've also linked in the chat. So this is just a nice, easy site to spin up sort of areas to write code. So I'm writing in JavaScript here, but you can write Python, C#, loads of other languages. And I find this is the easiest way. If you've never programmed before, you can do this and you don't have to install anything. You don't have to manage any versions or package managers or anything a bit more complicated. You can just sort of get in and start writing code over here like 2 + 2. So that might be your first line of code. So it's pretty straightforward, but otherwise let's get on with it. So day 16, the packet decoder. As you leave the cave and reach open waters, you receive a transmission from the elves back on the ship. The transmission was sent using the buoyancy interchange transmission system bits, a method of packing numeric expressions into a binary sequence. Your submarine's computer has saved the transmission in hexadecimal, and I'll just scroll down to see our puzzle input. Wow, there's a lot to read here, what the heck. So this is my puzzle input. So everyone that signs up for this site will get normally a different puzzle input. So this is what our input for this problem looks like today, but yours will be different, so your answer will be different, so you can't just copy my video. Right, where were we? The first step of decoding the message is to convert the hexadecimal representation into binary. Each character of hexadecimal corresponds to 4 digits of binary. I'm not going to go into that. We can talk about that for an hour. The bits transmission contains a single packet at its outermost layer, which itself contains many other packets. The hexadecimal representation of this packet might encode a few extra bits at the end. These are not part of the transmission and should be ignored. Every packet begins with a standard header. The first 3 bits encode the packet version, and the next 3 bits encode the packet type ID. These 2 values are numbers. All numbers encoded in any packet are represented as binary, with the most significant bit first. For example, a version encoded as the binary sequence 100 represents number 4. Packets with type ID 4 represent a literal value. What the heck is happening? Oh, there's loads of stuff here. Literal value packets encode a single binary number. To do this, the binary number is padded with leading zeros until its length is a multiple of 4 bits, and then it is broken into groups of 4 bits. Each group is prefixed by a 1 bit, except the last group, which is prefixed by a 0 bit. These groups of 5 bits immediately follow the packet header. For example, the hexadecimal string D2FE28 becomes... What's happening here? Hello, Alex. Hello, my homie. Below each bit is a label indicating its purpose. Okay, that's what it means. So VVV, the first 3 are the packet version. The next 3 are the packet type. The 5 bits labeled A start with 1. Not the last group, right? So there's a group there, a group there. Oh no, a group there. And the last group there starts with a 0 and then is padded with zeros afterwards. So this packet represents a literal value with binary representation, or 2021 in decimal. Every other type of packet, any type with the packet ID other than 4, represents an operator that performs some calculation on 1 or more sub-packets contained within. Right now, the specific operations aren't important. Focus on passing the hierarchy of subpackets. An operator packet contains one or more packets. To indicate which subsequent binary data represents its subpackets, an operator packet can use one of two modes indicated by the bit immediately after the packet. This is the length type ID. If the length type ID is 0, then the next 15 bits are a number that represents the total length in bits of the subpackets. This is awful. What's happening? If the length type ID is 1, then the next 11 bits are a number that represents a number of subpackets immediately contained by this packet. Finally, after the length type ID and the 15-bit or 11-bit field, the subpackets appear. For example, here is an operator packet with length type ID 0 that contains two subpackets. So that's fine, that's the same as before. The length type ID is just this number 0. The 15 bits labeled L contain the length of the subpackets. One second. There we go. Sorry, apologies. Just had a phone call. Right, so we've got those 11 bits containing the first subpacket, a literal value, and the 16 bits labeled B contain the second subpacket, another literal value, and then we've got our spare numbers at the end. The total length indicated in L was 27, right, so I see. How do we know one of them is 11 bits and one of them is 16 bits? I don't know. After reading 11 and 16 bits of subpacket data, the total length indicated in L27 is reached, so passing stops. So another example here is an operator packet. So we've got V is 7, packet version 7, the packet ID is 3, length type ID is 1, so there is, the length is an 11-bit number representing the number of subpackets. No, the number of subpackets. Is that the difference between this one? This one was the length of subpackets, was it? Right, okay. So there's 3 subpackets afterwards. And they're all 11 bits, are they? And then we've got the extra paddings at the end. That one looks a bit easier. For now, parse the hierarchy of the packets throughout the transmission and add up all of the version numbers. That's quite easy. Okay. I guess the difficulty there is that we need to figure out the length type ID in order to figure out where the bits end before we can get the type values. Okay, so we've got a lot of examples here. Let's go back to our easiest example to start with. Although this one doesn't have a... Yes, because this one's a literal value, so this is the first thing we need to deal with, though we don't even know that the first number we have is one of those. But oh well, let's deal with that to begin with. So that is our input. And I've already left a little snippet of code in here that should read that into an input array for us. I guess we don't need an input array yet. We don't need to think about splitting on anything. So I guess how am I gonna figure out where this item ends? I guess I need to crawl through and learn enough about this to figure out where the end is. So I need to convert this into a hexadecimal. So is it bit by bit? I think it is. So first we need to convert it to binary. Okay. I'm going to use somebody else's function for this since we're already 10 minutes in. JavaScript. There we go. So we can try that out with some numbers. Hex to binary. Doesn't use a string. I only need 3-digit binary. Why would it give me? No. I'll just make that up. Pass an x2 string. Oops. That's better. Let's try some other ones. 0, 1. Yeah, that looks good. So now for each item, where am I? Is it input? So I can do input.split. Give me that separately, so then I can do that.map char to hex to hex to binary char. There we go. Then I just need to join that. Join. Ta-da. Right, so copy that. So just to break that down, we're splitting the input, we're mapping over it with our new hex to binary function, and then we're joining everything back up. And I'm just passing in that to say split on every character and join without putting anything in between those characters. So binary equals that. So now I've got the binary equivalent of the number I started with, which should be this. Looks about right. Then next, I guess I could try and like tag these characters. So I could say let's call it version equal binary 0 to 2. Oh, that's Python, sorry. Slice 0 to 2, 0, 1, 2. Maybe it needs to be 3. Let's see if that gives me my first 3. Yep. Now I need to convert that to decimal to actually get any use of that. So convert binary to decimal, JavaScript. There we go, version is now 6. Packet type is type equals pass int. Similar code, binary slice, I want up to 3, up to 6. Do I want 3 up to 6? 3, 4, 5, I think so. And I need that 2 to convert. Type is 4, type is 1, 2, 4. 4, nice. I'm just going to leave a note to myself, if 4, then literal value. Then next we need to, and I'm just thinking, is there a way I can sort of cheat this and say, okay, I know that this is 4. No, I need to sort of chunk through the next 5 digits. How am I even going to figure this out from the... I kind of need to like convert the entire string I'm going to get into binary and then go through it piece by piece. So I kind of, yeah. So now I need to like be jumping through looking for the next 5 from this point that is a 0. Process that next 5 and then remove any zeros I'm seeing after that 5. No, because there could be a 0 for the version at the start of the next one. So it's about the number of... I guess, okay, fine. I can't grab the binary part in its whole here. I just have a starting point. So I guess I need to do like let remaining equal binary dot slice. We're going to start at the if literal value. That give me everything onwards. Is that my number here? 1 0, bunch of 1s, 3 zeros. Yeah. So then I should be able to get remaining dot length. It's 18. And I want to iterate through every 5, I guess. So I can do for start. To know let start equal 0. Start is less than remaining dot length start plus equals 5. Console.log start. So that should give me, well, it should say 0, 5, 10, 15. So that would be 0, 5, 10, which is 0, and it should stop. 15, so it'll do 1 extra. console.log. Can I get my Can I do that? Will that give me my characters? Yes. So I guess in here I can get my pieces. So I can say console.log remaining .slice start plus, I need to be +6. Oh, not JavaScript again. Nice, we got all our pieces there. So that's first bit, next bit, and this is garbage. So then we should be aware of, but how do I know? I need to trigger something when this first 0 is detected, basically. So console.log start equals 0. No. Remaining start equals 0. Is that right? There we go. So at that point, this is the last one. But I'm just right. Yes, I need to figure out. So I can figure out how many pieces I have left by doing like the number I want to get here is 20, and I want to say, you know, remove the difference between. I guess I want to say. So when I'm at that point, I know I know the next one is position 15, and I want to do. Now, how would I know? Because I know I have enough bits to represent. Why do I have enough bits here to represent 16 things? Oh, it includes these bits. So far the bits used have been, right, so total bits equal binary.length. Oh, it's not binary.length, it's input.length times 4. Total bits isn't really the right way. I guess it is. So version and type will cost us 2 of those bits, which gives me my 18. Sorry, that gives us the 18. So what does knowing that there's 18, and when did I know there were 18? I can't do this because I won't know that when there's 2 of them back to back. So I guess the question becomes how many 5s fit into 18, and it's 3, which will be where the 0 is. But I won't know the 18 because I don't know the length yet. So I need to determine this 18 from what I'm seeing here. But again, I don't know. I'm looking, right, okay, this is it. I need to find the first 0 on a 5th index after starting. But then how do I don't know how many Like, that works fine because there's 3 zeros, but if there's 2 zeros or 4 zeros, or if the next version is version 0 or 1 even, then that would have 0, 0, 0, 1. So I can't just assume that those zeros carry on. It could be prepended with something like this, right? Maybe I'll put a little bit extra in here. I'm just going to put a 1 in. And so you see now it keeps going, even though it shouldn't. So our clue to that is I suppose this should never be more than 4, but it could be. I guess we're limited by the hex. The hex values must all represent a packet, right? Is it always 5 bits? No. No. Of course it's not, because there could be different numbers of sub-packets. This is a very hard one. So I guess the question I'm struggling with here is that this could end in another. If this ends in 001, how do I know that this isn't just more of my binary number at the end? So I guess because we know we would know reading through, we've already figured out the version number. We already know it's literal. So we know that we're starting to read a binary number. So from seeing this 1, we know the next 5 digits are fine. From seeing this 1, we know the next 5 digits are fine. From seeing this, we know the next 5 digits are fine. But then we know that the next few digits are overflow from the bits we've seen so far. So at this point, we've seen, I guess, 21 digits, and we know that 21 isn't a multiple of 4. So is that where the extra 3 comes from? And that's all we need to know? I think that might be it. So let's get back to this. get rid of that. And we know at this point we've seen 15. We know that we had that plus 6. So is that, where did I get 15 from? We know that the 15 is going to be the starting position of the end, but it's actually 15 plus 6. Oops. Right. So from this position here, we should be able to figure out the next, how many digits are false. How do we get that? I guess we can do 21 divided by 4, and then we just need ceiling it. So 21 divided by 4, we can do math.ceiling. Oh, can we not? Math seal. Okay. Probably wouldn't have a capital letter anyway. Right, so that gives us our 6. So that's how many binary bits we have. So if remaining start equals 0, then we would be at 10. So we want to do console.log this. This has remaining start plus 5 math.seal divided by 4. I think that needs a bracket there. This has 2. 2 what? This has 2 hex bits, hex characters. It should say 6 though, so it's not right. Remaining start, because it should be start instead, it shouldn't be getting a binary character, which is why it's so low. This has 5 hex characters, which is not true. So when it's at 10, because it's not got our 6, so plus 6 for our types. And it should be ending the first time it runs. So I can call break in here as well. That should end our for loop. There we go. That's looking good. So let's get rid of all that. Let's get rid of all that. Okay, so is there an example of a longer literal one? That's our best example of a literal packet, it seems like. I guess I could just add a couple more of these and it will continue to find a longer literal. So that's looking good. The next step is, I guess, we could have 2 of these back to back, right? And it's not going to work now. So we need to sort of have like a sort of a notion of a read head, I suppose. So we should still have the whole thing in binary, which is fine. So all this needs to go now. So for let read position equals 0. Ooh, can I do a for loop? I guess we can sort of push things into our reader, I guess. Read position is less than binary.length. Read position plus plus. So log, I want to just read things out. So we go reading character like that. So that will read all of our characters. Let's actually get rid of that second one for now, just to make sure that this is doing what we think. So for the first, I guess we want to do like a while. So let reading, what's it called, label, reading version equal true. And then let if reading version then let version equal this, and we're just going to push this character into version plus equals read binary. And then I can do if reading, I can just do if version dot length is less than 3. I guess I could put this in that. Else reading version equals false. Do I need that? Do I even need reading version? Version is our 110. I guess I'll put an else if version dot length equals 3, then we need to convert the version. Well, I guess this is where we could say reading version equals false. And then we could say if reading version and version length is less than 3, then we could say reading version equals true. That's set to false, and we could convert version to real number, but I guess that kind of changes this condition as well, which is kind of annoying. Version 2, so now we should get version is now 6 again. Okay. And when that is done, we could say reading type reading type is going to start false. Here we can set reading type to true. I feel like I've never ever written code like this. So if reading type, then we kind of want the same thing. Pretty much exactly the same thing actually. Type. Can I just take all of this? Just change these to type. Ooh, guess not. Because it should be type reading type. It is reading type. This should be reading type. That should not be turning it back to true. In fact, that should be false. Type. Ew. So if reading type is turned on, which it should be at the 4th position, then maybe let's put some stuff in here. Console.log to version, console.log adding to type. So it's always adding to type except at the start, which looks about right, except for the extra adding to type. Reading type, if type.length is 3, so why isn't type.length 3? I'm not adding to it twice in the same. Because this doesn't have the version check as well, so the type length check. It's a nice little heart right there. Hello Alex, I noticed you. Sorry, I closed all of the windows when I had to go be right back. Right, so now type is 4. Good. So now we're at, how have I only written like 30 lines of code? This feels like I've been writing for ages. There's a bit more. Right, so reading binary, well, let's call it reading literal, since that's the type we're dealing with, is false to start with. But once we get here, reading literal is equal to true. So if reading literal and so now we're looking for like a sort of a end last nibble found equals false perhaps, and we can go and not last nibble found, and we also want to check if this is the fifth character, I suppose, because we actually need to store it. So if, I guess now let's just add it to our binary. Oh. So that would just get everything, which is almost what we want, but we want to actually mark that we're at the end. I guess we could try and remove these zeros, since they're nothing, right? The 3 zeros, yeah. So in order to do that, if read pos if the reading position is a multiple of 5, is 0 a multiple of 5? Yes. Yes, okay. So if read position minus 6 mod 5 equals 0. So we got log binary read pos, so it should be 1 1 0 0. Does it never get it? It's not in there. It should definitely be getting it for this one, for example. Is it just doing 6 mod 5? Yes, it is. There we go. 1 1 0 0. Is that our 5? It's our first digit. So that will be 0, 1 2 3 4 5. Read 1 2 3 4 5. Read 1 2 3 4 5. Read. And that is our last one. So we want to do something if it's 0. If this is equal to 0, then that's when we trigger our last nibble found equals true. But we need to continue writing to it for 5 more goes. So maybe we could call it. So it'll stop running early, basically. So there we go. So it stopped when it found the last bit, which was this one, which makes sense when we want it to stop on this one. So it needs to continue. Sorry, this was it. So it needs to continue for the next 5. So we could do something like last nibble position equals +1. And then when we find it, instead we say last nibble position is equal to read position +5, is that right? And then we can say here, I guess then we could do like if last nibble position equals read position. Then we say being literal, we still need to read literal. For now, I'm just going to do last nibble found equals true because that's our flag. So instead of that one, we'll trigger it later, but not really happy with that. So there's our binary value. It seems to have ended at the same position. Last nibble position, if last nibble position equals read position, what? Why is this triggering? It's not triggering. So what is causing binary value to be shorter than binary if it's not triggering? Because it's not shorter, it's just the binary part. So everything is being prepended. Everything is hitting this. Oh no, it's not. Everything is hitting that. This is not triggering here. Yes, I know that. What is the read position? What is the last nibble position? If binary read position is equal to 0, so if the number found is equal to 0, it should be doing this. This is triggering here, so we are seeing a 0. It probably is a string. There we go. Binary value. That's looking better. So now it is ending right there. So it's leaving our remaining 3 off as it should be, which means that we are now reading. So now we're reading. What are we reading? Reading overflow, I guess, equals true. So we need to figure out how much overflow there is. If, oops, not in here, we don't. If reading overflow. So we figured out before how many pieces there would be. How did I get that ages ago? Once I found the 0, right? So when I found the 0, which was here, I needed to do this. So let's bring this back. Except it's not called start, it is the current read position. 7 hex characters. It should be 6. Why is it 7? Ah, because we already took the 6 off. No, we didn't. Reposition -6. Am I not taking it off? Is the addition of that 6 doing it? Why is that? I had to add 6 before because I removed the numbers out, but I'm not doing that this time. So if there's 6 characters, I need to know my position when I finish reading. So when do I finish reading? In here, right? Last nibble found is true. Which means that I need to stop reading the literal. Equals false. And I need to start reading the overflow. Right, so same as before, I guess. We need this, but it needs to be called overflow value. And that only needs to run up to is less than needs to equal this number, that's our 6. And reading position needs to be less than hexchars times 6, maybe -1. Let's see. Ooh. I got that off by 5. Killer. Oh. Reposition is less. Reposition should be less than. No, that will go the wrong way, won't it? It's starting too early. I think it's being triggered at the point of the start of the last nibble. So I kind of want this here, and if last nibble position plus 5 is equal to that, then I want to trigger these. Oh, why? Because it's still in there. Phew. Is this getting worse? Last nibble position plus 5. Let's console.log. Last nibble position plus 5. Oh. The last nibble position is like the final position. It's because I should have renamed it when I already did the plus 5 to it. So it definitely shouldn't be plus 5. Which means it was in the right place before. This was fine in there. It's a bit annoying. Right. Well, we've just about run out of time, so I'm going to leave it there. Tidy this up a little bit. I'm pretty happy with that. I mean, that was a really, really awful question. I feel sorry for anyone who's just chosen to watch this one first, because normally they're a bit more fun than what we just saw, but that was just sort of writing a binary digit reader, I suppose, which may be fun to some of you, but not really to me. But yeah, I will leave it there. Thank you very much, everyone, for watching, and I'll see you next week. Bye-bye.